Okay. Hi, we're doing the painted cube challenge where we have multiple cubes with different dimensions that will be completely dipped in paint. The challenge is to find the faces that are covered in paint and how many there are. So we made a chart to show what we found. And we showed all the dimensions for the amount of faces painted. So we found that in a 2 by 2 by 2 cube, there would be 0 cubes with 1 face painted, 0 cubes with 2 faces painted, and 8 cubes with 3 faces painted. With 3 by 3 by 3, we found 6 with 1, 12 with 2, and still 8 with 3. Now, we also found that 8 is now a constant no matter how far you go, because it's on the corners of the cubes. We also generally found the pattern rule for this, which is you just add 12 each time. I didn't write it here, but there's also a pattern rule for the number of cubes that have no faces painted. Generally, what the rule is you find the dimensions of 2 terms ago, and you do length times width. So 4 times 4 times 4, the amount of cubes that have no faces covered, no faces painted, will be 2 times 2, 4. We couldn't find an equation, something for this, a pattern rule, so I'm going to hand it off to Yasin, with the equations.
Yeah. So for the number of cubes with 1 face painted, our equation was side length minus 2 times side length minus 2 times 6. So let's use 4 by 4 by 4. So 4 minus 2 times 4 minus 2, which is 4, then times 6, which is 24, which is also the answer. I have an equation for this as well that's completely different than add 12 every time, which is the pattern rule for this. But I don't think we need to explain it because we have a pattern rule already. And our strategies were, so we made a chart, we used logical reasoning, and that's basically it.
And find a pattern.
Yeah, and we found a pattern.
So this is generally the chart we did. What we found out is that no matter what the cube is, as long as it's a cube, it will have 8 faces that have 3 painted, which remains a constant. We also found a few pattern rules and equations, and yeah.